Hello everybody. Now we are in the third week of this course. In this week we will have 5 lectures, and all these we will discuss in all these lectures we will discuss the processing and preservation principles. So, the first lecture of the third week or 11th lecture of the course is today. In this next about half an hour or so, we will have the basics of processing and preservation. The concepts that we will be covered include aims of food preservation, principles and methods of preservation and processing, control of pH and water activity, combination technology concept, and finally, I will also give you an overview of the novel and emerging technology in the processing. In the last lecture, the last week, we discussed about the various methods to determine food quality attributes QA and QC, where we studied that what does quality means, what is safety. So, safety is the first prerequisite of any food. Food safety implies the absence or acceptable and safe level of contaminants, adulterants, naturally occurring toxins, or any hazard that may make the food injurious to health on an acute or chronic basis. So, the food at the time of its consumption should be free from any such hazards or undesirable toxin or chemical components. So, in a broad sense, this is taken to mean that a food is free from any harmful chemical or microbiological contaminant at the time of its consumption. Okay. Safety concerns in the food processing include microbiological contamination, contamination arising out of packaging material, contamination which may come from the chemicals or additives etc. used in the processing, or equipment which are used in the processing. If they are not properly cleaned etc., they may also be a source of contamination. So, in general in this figure you can see here that yes, the effect of processing on safety and quality, and these are both interrelated. That is, if the process, if you have a more severe a process, you will get a better safety of the product, but that it may result to the quality result in deterioration of the quality. So, in the processing one has to make a compromise, find out that is what is that particular severity level or combinations etc. of the process parameter, where you can get a food which is of good quality as well as at the same time it is safe for consumption. The food, all the products following harvest may lose quality at some rate or other in a manner that is very dependent or highly dependent on the food type and composition, formulation, storage and so on. And here in this figure you can see that in the value chain, starting from the ideal raw material until it passes through various stages till it reaches to the consumer table. So, in the ideal raw material, if you say that potential quality is here, which is X or you can say 100, then due to one or the other reason, that is maybe that good horticultural practices or other practices, that is the material, actual raw material which you get in the processing, that itself may be little bit inferior, because and then each and every stage you can see that, except that one stage when the product formulation stage, where by appropriate combination of various raw material or various components etc., you can get a desired quality raw material for processing. Otherwise, at every stage there is a huge quality loss. The reason being, because this material, food material which is being handled here, it is a biological material, and various agents like microbiological, enzymatic, physical, chemical agents are acting on it, and they bring about various changes. Okay. So, it is the job of that in the processing what we try to do, that this by having appropriate measures, we intend that the quality of the final product is as close as to the initial raw material, because this quality loss may be accelerated or minimized at any stages, and the total preservation of a food is therefore often highly multi-component, because these quality loss we have seen that there are various factors which influence this quality. So, this preservation is a result of a multi-component factor, as it seldom relies only on one factor alone. So, the principal quality loss reactions are therefore the principal targets of food preservation or food preservation technology. I will a little bit elaborate the major quality loss reaction, like in the microbiological factors there may be growth or presence of toxicogenic microorganism, or there may be growth or presence of infective microorganism, or just growth of spoilage microorganism. In the enzymatic reactions, there may include hydrolytic reactions catalyzed by lipases, proteases, or reactions catalyzed by lipoxygenases, enzymatic browning, chemical reactions like oxidative rancidity, oxidative and reductive coloration, discoloration, non-enzymatic browning, or nutrient losses. Physical reactions may be that mass transfer, movement of low molecular weight components from one place to other. There may be loss of crispness, loss of flavor, or freeze induced damages, etc. So, these various reactions and various chemical during handling, transportation, processing, the food may be subjected to all these things. So, what will happen? So, as I told you that processing or preservation steps is done to minimize these reactions, undesirable reactions. So, if these quality loss, if this consequences, that if they are not properly controlled, the consequences may range broadly, like it may be just if this poor keepability, color, flavor, texture, etc. If that is the nature of the quality loss, it may just result into the lower quality of the marketed food, it may reduce the marketability, okay. Or if there are potential microbial hazard, unacceptable rate of oxidation, unacceptable change in texture, its consequence may be inability to distribute and market the product. Or but if there is a presence of toxin, presence of pathogenic microorganism in the food, it may lead to the hazard to the consumer. So, the consequences of these quality loss reactions or the failure of the technology may lead to the may range widely from the lower quality of the marketed food as well as hazard to the consumer. So, one has to be during processing and preservation, one has to be very, very careful to take these reactions. Okay. So, what are the major targets for antimicrobial preservation techniques? That is, major targets may be either poisoning microorganism, as I told you that most of the spoilage in the food, major culprit, major cause is the microbiological reactions, and in the microbiological it may be either poisoning microorganism or spoilage microorganism. So, accordingly most of the food preservation technologies, they work on these principles. In the poisoning microorganism, like presence or multiplication of infective microorganism, that is, for the infective microorganism, its presence is also not desirable, it may cause problem, that is, those are Salmonella, Listeria, Campylobacter, etc. Or multiplication of toxicogenic microorganism, bacteria like Staphylococcus aureus or Clostridium botulinum, when they grow in the food, they produce toxin. So, in this case, that is our major targeted, that is, these should not be present there as well as they should not be allowed to grow inside the food. Whereas the spoilage microorganism, when they grow there, multiply there, they may cause generation of minor metabolic products like thiols, esters, amines, peroxides, generating discoloration, off flavor, etc. Or they may secrete different enzymes like lipases, proteases, amyloidases, polygalacturoses, etc., causing flavor and textural changes, or there may be even presence of physical presence of the biomass like visible presence of microorganisms, slime, haze, mold colonies, etc. Okay. So, accordingly that let us see that these are the since microorganisms, their growth, etc. That is, we have to understand what are the various favorable conditions that influence that favor the growth of growth and multiplication or development of microorganism in the food. And if we understand that, our job as a processor becomes simple. Okay. So, various factors which affecting the microbial growth may be intrinsic factors like the chemical and physical factors within the food, that is within the food from which a contaminating microorganism is inextricably in contact. Processing factors are the factors which are applied to food during processing for improved preservation. Okay. These factors also may influence the growth. Extrinsic factors are those factors that influence microorganism in food, but these are applied from outside the food and they act during storage like temperature of a storage environment, relative humidity of a storage environment, etc. Then the implicit factors, these include factors that are related to the nature of the microorganisms themselves and to the interactions between them with the interactions between the microorganism and the environment with which they are in contact during growth. And overall in this there is a net effect, that is net effect means net effect of all these factors. This takes into account the fact that many of the factors strongly influence the effect of each other on microbial growth and survival. So, the overall effect of combination of factors may not be readily predictable, but may be usefully greater than the perceived effects of the single factor. Okay. Then the factors in this table I have summarized that all these physical factors, that is intrinsic factors like chemical, nutrient, pH and buffering capacity, oxidation reduction potential, antimicrobial substances, physical, that is ERH and water activity, ice and freeze concentration, colloidal changes or processing factor, that is changes in the food composition during processing, changes in the microbial type, changes in the microbial number or changes in the microstructure of the food, etc. So, these chemical physical processing, they are intrinsic factor. Extrinsic factors, that is the, as I told you, equilibrium relative humidity during storage, temperature during storage, oxygen tension, etc. and implicit factors like microbial growth rate, that is the synergic effects, that is sometime one microorganism grows and it produces the favorable environment for the growth of the other microorganism, or there may be vice versa, that is antagonistic effect. Okay. So, all these things affect these are the factors which affect the microbial ecology of a food in general or fruits and vegetable in particular. Okay. Then now once having this information, this knowledge about the safety and how the food spoils and what are the various factors, microbial quality, and then we come to the preservation, like the preservation in the either by preservation or by processing, we try to control these growths, these reactions, etc. So, in the preservation, it is the treatment of food to prolong the time for which they can be kept before spoiling. Okay. While most preservation techniques are primarily based on the prevention of growth of the food spoilage and poisoning microorganism, the preservation of other quality attributes is also of major concern, additional concern, that is it must be seen, otherwise your preservation, if by having a more severe process you can extend the shelf life, but it's if its quality is deteriorated, it is of no use. So, as I told you earlier in that graph, that one has to make a proper compromise, that is the quality and safety is properly maintained. So, the traditionally used food preservation techniques work on the principle, as I told you, on controlling the factors which influence the microbial ecology of the produce or other spoilage agents, and these are, that is there are three sets of factors, like one, the slowing down, that is one set of factors which slows down or in some instances complete inhibition of the microbial growth. and accordingly there are one set of technology, preservation and processing technology. There are other, particularly that direct inactivation or killing of the targeted bacteria, yeast or mold, particularly if the bacteria of concern is a toxicogenic bacteria or pathogenic bacteria, as you have seen in the earlier slide. So, there you have to have adopt a method which kills or inactivate that microorganism. And there are also one set of technologies, preservation technologies, which restrict the access of microorganism to the food products. Okay. So, we will take up little bit, that is the one set of technology which work on the principle of slowing down or inhibiting the growth of microorganism in food, and they include lowering of the temperature, because you have seen that temperature is one factor which influences the rate of microbial growth rate. So, they lower down the temperature like chill storage or freezing and frozen storage. Then nutrient restriction, where that is there is a compartmentalization of aqueous phases into water in high emulsion, that is the nutrients which are present in the food material, they can be bound, they can be compartmentalized in such a manner that the microorganism is not able to utilize that particular nutrients. Then there is a decreased oxygen like vacuum and nitrogen packaging, because oxygen is another factor which influences the growth. Increased carbon dioxide, that is control atmosphere storage or modified atmosphere packaging. Then chemical preservatives, addition of inorganic compounds such as sulfides, nitrites, organic compounds such as propionates, sorbates, benzoates, parabens, etc., or antibiotics such as niacin, pimerazine, and so on. Even the alcoholic fermentation like brewing, vinification, fortification, etc., that is apple juice or even grape juice is preserved by converting it into a wine through alcoholic fermentation. Then reduced water activity or raised osmolality like drying and freeze drying, curing and salting, conserving with added sugar, that is where the water is removed from the food material, water activity is lowered down. Okay. Then in acidification is another method like addition of acid, lactic or acetic fermentation like this pH management or even pickling, etc., is the process of the fruits and vegetables which work on these principles. So, these sets of the methods which you have told, these are the factors on the basis of which these principles work, and in all these methods there is one thing is important, that the bacteria or microorganism of the concern, it will not die, it just slows down, it goes into the dormant state. Okay. It goes in the stationary phase, but mind it, as soon as these factors are removed, for example, you have kept a food material in a chill storage. So, as long as it is in the cold storage, chill storage, the microorganism will not grow, but as soon as it is taken out of the, once you have removed that stress factor or factor, the microorganism will again, when it finds a favorable environment, it will grow and multiply. So, these are in all these sets of technologies it has to be taken. So, it as a matter of rule that these commodities, when they are preserved using these technologies, after these factors are removed, after they are taken out of their storage environment, they should be consumed as quickly as possible. Then the other set of technology like where the direct inactivation of microorganism, that is or killing of the microorganisms are there. So, here you have to give some sort of energy, either heat energy or radiation energy for killing the microorganisms. Okay. That is in the heating, it may be pasteurization, sterilization, details of all this pasteurization, sterilization, deodorization, radicization, ratapartation, etc. These are the technologies of heating or irradiation. We will take up separately these aspects in another lecture as well. So, these are the some of the technologies where that is the energy is put into the food and the microbial cell, and it kills the microorganism. Maybe when you are eating the food, then it may result into the denaturation of the body enzyme system, or its other normal physiological process are adversely affected, or they are stopped, and the microorganism, particularly or enzyme, particularly inactivated microorganism, get killed. Then there is other technique like restrictions or excess of microorganisms in food. There may be decontamination that is decontamination, lower down the level of contamination of the packaging material or of the food, like treatment of the ingredients with, by for example with ethylene oxide, or treatment of the packaging material with H2O2 and or heat or irradiation, etc. And then finally that process, aseptic thermal processing and packaging without recontamination. Make sure that is the first you decontaminate the components and then pack it in an aseptic environment, and this is the principle of aseptic processing and packaging. And this technology also we will take up detail, because these are the technologies which are being used for the preservation of foods. Now come to the processing. That is, processing is the set of methods and techniques which are used to transform raw ingredient into finished and semi-finished value added products. Why do we need processing? To extend the shelf life and allow time for distribution, scale and home storage, to increase the variety in the diet by providing a range of attractive eating quality, sensory characteristics or organoleptic quality, reduction of wastage, increase in farmers' income by getting better prices, to increase income for the manufacturing company, or to eradicate world hunger by making food accessible with affordable to everyone. So these are the objectives of processing. Here I have tried to show you a generic flow diagram for a typical food process. For example, for any, when you go for processing any food, they are required, that is sometimes ingredient preparation, that is primary processing, go for sorting, grading, converting into fine powder or paste or juice, whatever is there. So that is the ingredient preparation, and these once ingredients are prepared, then there is scaling for formulation, either by automatic metering units or by individual metering, manual metering. That is the ingredients are taken as per the formula. And then invariably in all food process there is some mixing operation, either mixing of solid to solid, solid to liquid, liquid to solid, liquid to gas, gas to gas, whatever different types of. So appropriate equipments or machinery are used for mixing as per the formulation, and then after the mixed formulation is then sent to the processing, and then primary packaging. Sometime after primary packaging they are again secondary processing or main processing, secondary packaging, utilizing any storage. So this gives the generic flow diagram, process flow chart for any food process in general. Okay. Here I have given in this typical steps in food product development and engineering involvement, that depending upon one's engineering resources availability or financial availability, to identify the need and opportunity, what is needed and where there is opportunity. Then develop your concept, how you are going to meet that need. Okay. Test your concept. If the concept upon testing in the laboratory, if it is approves, go for the market production. Otherwise, if in the laboratory is fail, revise your concept. So sometime what happens, that is your concept is tested in the laboratory in the positive, but when you go for large scale production or market production, your technology fails. Then in that case it means that in your concept itself there is something wrong. So you have to develop again concept, new concept, and go for this you should do until unless in the large scale production you find that as the material or product is to the desired attribute whatever you are wanting. But mind it, that is in this time, this timeline should be as short as possible. Okay. Otherwise you will be just moving here this, and your competitors, they may bring similar product into the market. So one has to be careful that is do this, but as quickly as possible. Here in the slide I have given a SWOT analysis of the food processing, like strength, abundant availability of raw material, priority sector status for agro processing by the central government. There are vast domestic market of the processed food. Then weakness, however, there is a low availability of adequate infrastructural facility, lack of adequate quality control and testing methods as per international standards. There are inefficient supply chain due to a large number of intermediaries involved in the value chain, high requirement of working capital, most of the food processing industry, inadequate developed linkages between R&D labs and the industry, and seasonability of the raw material. So, these are some of the weaknesses. Okay. So, where are the opportunities? Like large crop and market material base offering a vast potential of agro processing activities, rising income levels and changing consumption patterns, and finally opening of global markets. These are the opportunities. Okay. Threats, that is affordability and cultural preferences of fresh food, high inventory carry cost, high packaging cost. These are some of the threats to the industry. So, commonly used methods for processing of and preservation of fruits and vegetables include removal of water or moisture like evaporation, concentration, dehydration, drying, salting, application of heat like pasteurization, sterilization, smoking, lowering of temperature like refrigeration, freezing by indirect contact with refrigerant, air blast freezing, freezing by direct immersion, control of oxygen like fermentation, canning, and pH reduction, pickling, etc. And all these methods we will take up details of their methodology, concept, and even equipment, etc. in the next classes. Then lowering of the temperature like freezing by direct immersion, you can see here in the figure. Fruit may be frozen by being placed in a contact with a metal surface which is cooled by refrigerant, or packed in a can and is cooled by immersion in a refrigerant. Then freezing by direct immersion, that is a fruit product either packaged or unpackaged. You can see here it is frozen by immersion or by spraying with a frigent that remains liquid throughout the process. Air blast freezing, the material is to be placed frozen, may be placed on a moving belt in which the cold air is confined in an insulated tunnel. So, these are some of the. Similarly, addition of heat like pasteurization, where the food is heated below 100 degrees Celsius. It is a mesophilic microorganism or pathogenic microorganism are taken care of here. In acidic food, it is used to extend the shelf life of several months by destruction of the spoilage microorganism and enzymatic inactivation. The sterilization, the food they are heated to high temperature for long time to destroy microbial and enzymatic activity. That is sterilized food, they have a long shelf life and there is no commercially, that is the viable form of microorganism are all stopped. That is we do the commercial sterility. Then smoking also, the addition of smoke and heat preserve the food by the action of chemicals from the smoked wood and the partial drying of the food. Then reduction of pH, that unfavorable for the growth of and multiplication of microorganisms. That pH is, you can see here in the figure, that is unfavorable, that is both extreme, this side or that side, extreme pH. Okay. So, this is the, it is done by expelling the gases present in the intracellular spaces of the tissue or by creating barrier for all, that is pH is brought to the desired level which is becomes unfavorable for the growth. Then control of oxygen, that is the fermentation, control action of selected microorganism is used to alter the texture of food, preserve food by production of acid or alcohol or by to produce subtle flavors and aromas. Similarly, the canning, it is a method of preservation of food in which the commodity is processed and in hermetically sealed containers like metal, glass, etc. through the agency of heat. So, it gives extended shelf life of more than 2 years or even more than that. Salting, preservation of water or removal of water or moisture, that is here, that is we are trying to control the water activity. Okay. Salting, salt kills and inhibits the growth of microorganism by drawing water out of the cell of both microbe and the food through osmosis. Drying, removal of water content from the food material to a desired level. Dehydration, application of heat under controlled conditions to remove the majority of the water to equilibrium moisture content in a typical food evaporation. Evaporation is the partial removal of water from an aqueous solution to produce a concentrated final food product. Control of pH, that is pH is an important factor affecting growth of microorganism in the food, because it affects microbial energy metabolism involving the buildup of hydrogen ion concentration across membranes and the microbial enzymes activity and stability of cellular microorganism. Moreover, pH also affects the sensory properties of many foods. Okay. So, pH can be controlled by the choice of raw material, okay, and by the addition of or in situ fermentation of acidic or alkaline low molecular weight substances. So, growth of microorganism may be inhibited by either low or high pH. The minimum pH for the growth of microorganism as well as the rate of inactivation of microorganism by acid is affected by the nature of acidulant, the presence of other inhibitory factors like low water activity, preservative, low temperature that may interfere with the energy metabolism or increase the need of maintenance energy, and the ability of microorganism to react to acid stress to maintain passive or active pH homeostasis. So, what is passive pH homeostasis means? Microorganism either prevent external proton from entering the cell or increases the buffering capacity of their cytoplasm by synthesis of the glutamate and or citrates, etc. At active pH homeostasis, cell maintains their cytoplasm pH through metabolic activity, and mind it that till the pH homeostasis is maintained inside the cell, the microbe will survive, but once it is homeostasis is disturbed, it will. So, microorganism in fact it try to that is maintain their either passive or active pH homeostasis. They try to manage, they try to fight with the stress, etc. Okay, and many times they they exhaust all their energy and they end up dying. Similarly, control of water activity and all the factors affecting microbial growth, death and survival in a food. The influence of water activity and vegetative microorganism and spores has been one of the most important and most importantly studies. The optimum water activity for growth of the majority of microorganism in the range of 0.99 to 0.98, okay, and some important common microorganism, spoilage microorganism, it is shown here. So, the every microorganism has limiting water activity below which it will not grow, it will not form a spore or it will not produce toxic metabolite. So, this is the principle of this method, and here in this figure we have just shown that how the various reactions they are influenced by the water activity. So, the minimum water activity for growth is always equal or lower than the minimum water activity for toxin production. Major advances in the control of water activity as a means for food preservation will be the contingent upon the improvement of food sensory aspects resulting from lowering of water activity and the refinement of techniques for controlling the water activity, because if you lower down the water activity, it adversely affects the sensory characteristics of the food. So, water activity can be controlled by either removing water using appropriate dehydration techniques or by adding appropriate amounts and types of salt or sugar in the food and allowing the binding of water. Other than the water activity and pH, preservation is generally achieved using heat by large scale inactivation of viable microorganism and a wide range of variables including the level of water activity within the product and the pH of the product influence the probability of the survival of the target organism in a given food product. Okay. Here I have just tried to give you combination technology, that is combination technology preservation techniques to establish a series of, the purpose here is to establish a series of hurdles or preservative factors that the microorganism are not able to overcome. Okay, they are unable to jump over or overcome, and these hurdles may be. So, here in fact the principle is that is instead of using a severe parameter of one process, one individual process, you use different more than 2-3 processes together, and therefore severity of the one process can be reduced. You get a better quality of the end product and the hurdles also, that the preservation is also. So, various hurdles like preservatives, packaging, ultra high pressure, pH, water activity, temperature, all this in the combination they can be used. Then novel and emerging technologies in the food processing, there are mostly the non-thermal technology like high pressure processing, irradiation, membrane technologies, microwave drying, ozone treatment, etc. They have their use in the fruits and vegetable processing. Packaging like active packaging, control atmosphere storage, edible packaging or edible coating. Then artificial intelligence, machine learning, deep learning, or zero waste supercritical fluid extraction, or micro encapsulation, etc. are some of the technologies which are used. So, in fact, some of these processes we will take up in the next classes to come. Okay. So, I will now summarize this lecture by saying that the food safety is the important or major concern in fruits, vegetables and plantation crops. Major quality loss reaction occur due to the growth or presence of microorganism, which will eventually lead to the severe consequences, and various parameters affect the microbial growth, which are classified into 5 factors, namely intrinsic, processing, extrinsic, implicit and net. Finally, the net effect, all these factors which give, and traditional preservation techniques such as control of water activity, pH, temperature. These are based on all these sets of factors. That is, most of the traditional technologies which are used for food preservation, they work on the basis of the principle of controlling these microbial or other enzymatic or such other activities. The combination of the traditional techniques, also known as hurdle technology, is widely used to stop or kill the microorganism with minimal processing. That is a minimal processing strategy which gives a better quality products. Okay. These are some of the references which have been used in this lecture. Thank you very much.